So hello everybody, I'm Ang Yee Feng. So now I'll be presenting a basic introduction video of statics, and the topic I'll be covering will be just the basic topics which are basic concepts: system, force system, equilibrium, analysis of friction in bodies and structure under static conditions. So let's begin. So first of all, the basic concept of static is just the same basic concepts as in physics. So they're just like something like length, time, mass, force, particle, and weight are involved. So I think most of you all must have understand this basic things. And also the Newton three law of motions. So the first law says that an object must be exerted with a certain force to move or being stopped. If there's no force, let's say that a moving object, we doesn't exert a force on it, right? It, it won't stop, and it will just travel with a constant velocity. And for the second law, it is F equals to ma, which means m refers to mass, a refers to acceleration. For the third law, it says that for every reaction, there must have been an opposite and reaction with the same magnitude, which means that if we, let's say that a stationary object, right? Let's say a pen located on being put on the table, but however, there's a gravitational force pulling it, right? But however, you must be wondering why it doesn't fall down and then penetrates to our penetrating through our table, since that according to the third law, there's a opposite reactions with the same magnitude, which means that there will be a normal force acting upwards, and the force is also 9.81 accelerations. So there will be the same force acting upwards. So this is considered the third law. So now the SI unit, there are two kinds of SI unit. First of all is the International Unit, which is SI, and also the US Customary FPS. So these two are used, but the more commonly used is SI unit, which is a meter, second, kilogram, and Newton. And there are conversion factor that can convert both unit from one unit to another unit, from SI to US customary, and also can be used for convert US unit to SI unit. And for force system, there are addition and subtraction. By viewing this diagram can be said as a basic introduction of force system, but it's not accurate at all. But this is a basic introduction and a rough picture of a force system. So if you see this, at this these questions, there's a hook there and there are two forces. So there are F1 and F2, but however, what is the final force, which is so-called resultant force, and also what angle it is? I think this one you all might have learned in secondary school physics, but it's quite easy. So we just use the Pythagoras theorem by finding an Fx, Fy, Fx, Fy, and then we will get an Fr. Wait, this one is F 100 Newton square, 100 Newton square, and 150 Newton square, and also 2 times 1. Oh, sorry, this one is the cosine law. Sorry, cosine law. We use a cosine law and sine law to find an Fr. Since this one is not a 90-degree angle, right? 90-degree angle triangle, so we can't use Pythagoras theorem. So Fr will be 213 Newton, and then we use the sine law. We can get the angle of the Fr, the resultant force, which is 9.8 degree. So for the force system, there are scalar notation and also Cartesian notations. For scalar notations, is 600 cos the Fr, that's x and y. Frx equals to 600 cos 30 Newton minus 400 sine 45 Newton. There's a negative sign since it's opposite, and also we assume that the above direction and the right direction is positive, while the left side and the right below direction is negative. For Fry equals to 600 sine 90 Newton plus 400 cos 45 Newton equals to 2.8 Newton. And then we find out the Fr by using the Pythagoras theorem, and then we will get 629 Newton. And for the vector additions, we can get the 67 point, by using a 10 negative 1, we can get a 67.9 degree. Tangent root, yeah, the tangent. And then the solution 2 is Cartesian vector notation. For Cartesian notations, it's much a bit different with the scalar notation. Cartesian notation is F1, F2. As you can see, F1 is 600, F is a force of 600 Newton, and I have an angle of 30, right? So this one we write as I and J. The I refers to the axis and J refers to the Y axis directions. So it will be 600 cos 30I and plus 600 sin 30J. And F2 equals negative 400 sin 45 degree I plus 400 cos 45 degree J. And for Cartesian notations, we don't have to we don't have to find out the value. We just make it to be Fr equals to F1 plus F2. So we will get 236.8I plus 582.8J. However, if we want to square them and then square root them, we will still get the 629 Newton. The answer will be the same, but to leave, we will leave it as 236.8I plus 582.8J as an answer for Cartesian notations. So univector is like this. The univector represents the angle directly from the direction of force towards the axis, y-axis, and z-axis. As you can see the difference of the diagram in between the left diagram and right diagram. The left diagram, the angle is not directly from an axis toward the F force, but instead the 60 degree means that the angle between xy plane and F force, the force F. The force F is 100 pound, and there's a 60 degree towards the xy plane, and then from the F prime there will be a 45 degree towards the axis. So F equals to 100 sin 60. Since we know that the vertical force is sin 60, right? We need to use the sin 60 to get the exact vertical force. So F equals to 86.6 pound, and then we get the F prime equals 100 cos 60 pound. We get a 50 pound. And then the fx, since we have a 45 degree in between the fx and also the f prime, so we use the cosine rule, the cos, and then it will be f prime cos 45, and the fy it will be negative f prime sine 45. Since it's the left side, so it will be the total f will be f equals 35.4 I minus 34.4 J by 86.6 K pound. And we need to find a value by square everything and square root. So we need to find a unit vector. The unit vector is the f divided by the italic f. So it will be fxi plus fxy fij by fzk divided by f. So it will be 35.4 I plus minus 35.4 J plus 86.6 K divided by 100. And the alpha, beta, gamma will be the direct angle in between the axis and the force. So this one is what we call as unit vector. So the purpose of unit vector is just let us to determine the direct angle directly, the direct angle from axis towards the force. So alpha is the angle in between x, and force beta is the angle in between y-axis and force, and gamma is the angle between anti-axis and force. So this is another example. So the force I on the hook shown in the area 2.31a specify the magnitude of F2 and its coordinate direction, blah blah blah. Okay, so for this one, as you can see, there are two forces from one hook. So F1, F2, and there's no angle given, there's no force given to F2, but we know the unit vector of the alpha, beta, and gamma of the F1. So we get the F1 equals to F1 cos gamma 1i plus F1 cos gamma beta plus F1 cos alpha, F1 cos alpha plus F1 cos beta plus F1 cos gamma. So we get 212i plus 150j minus 150k. And then for F2, we don't know the L angle, and also we don't know the force. So it makes it to be F2xi plus F2y plus F2zk. And since we know that Fr equals to F from S2, right, and also is given that S 800 Newton, so we add them together, and then we will get 800 j equals to 212.1i plus 150j minus 150k plus f2xi plus f2lyj plus f2zk. And then we just do the mathematical calculations, and then we will get f2x equals to 212.1 Newton, f2y equals 650 Newton, f2z equals to 150 Newton. And then we will get the answer magnitude of f2 equals to 7 Newton, 100 Newton. And then we will use the by using the reverse one, right? Since we know that the value of the force of the x f2 for the f2 axis is negative 212.1, right? So we use the reverse method to find the angle alpha 2, which is 108 degree, and beta 2 21.8 degree, and gamma 2 equals to 77.6 degree. So position vector. So the previous example, right, there's only force, but now we this another example includes the coordinates of 2 points or 2 points. So this point there's a coordinates, and we can know that the coordinates of A is 1 meter I, 1 unit to x, 0 unit to y, negative 3 unit to z. Then for B is negative 2 unit to x, 2 unit to y, 3 unit to z. So we need to find a distance in between 2 points. So we introduce an r, which is the distance between 2 points A and B. So we get negative 3i plus 2j plus 6km, 6k meter. And then we found the value by square root everything, and then square everything, and then square everything. So and then we find a unit vector, which is the negative r over italic r, and then we will get negative 3 over 7i plus 2 over 7j plus 6 over 7k. So by the anti-cos the value, we can get the gamma, alpha, gamma, and beta. Of the A and B. So this one, as you if you see a right diagram, the figure 2-35, this one it depicts an angle of the A-B position vector from the origin. So next we'll be combining the force vector and the position vector, and also the unit vector to make it to be force vector directed along line. So if you see there's a ABC line, line AB and line AC, and then on line AB there's a force of 100 Newton, and line AC there's a force of 120 Newton. So first of all, same thing, we get the unit vector RAB, the internet RAB, and then we will times with F, and then we get FAB equals 70.7i, then that's 70.7k, and then the same thing we go with AC. So and then we get the resultant force, which is FAB by FAC, and then we get 151i plus 40j minus 151k Newton. So for equilibrium, first of all, to understand equilibrium chapter, you need to understand the free body diagram and also know how to draw it. So the free body diagram, if you see at the left diagram, there's a object, a metal object, and there's 2 lines hanging on it at point A and point B. So there's a 2 line. The line represent the line holding object. So that must be a tension. So tension A and tension B, and the object have its own weight, which is 5 times 9.81. The 5 represent the mass, 9.81 represent the acceleration, gravitational accelerations. So it's 5 times 9.81. So take an example at the right side. So we have a solution, object D hanging by 2 lines, like line AC, AB, and line AB, line BC, and line BC has an angle of 45 degrees, and line AB has a triangle stating the length is 345. So the 345 can be used to identify the angle of line AB. So for XX, we use TC cos 45, TC, the tension C, the line is ECD. Tension C TC cos 45 minus 4 over 5 TA equals to 0. So as you can see, 4 over 5, right? So it's CAH. CAH adhesion and hypotenuse. So it's cosine cos. Yeah, cos. So actually it's the 4/5 represent the cos angle, but we don't know the angle, so we can just straightforward use 4/5. But however, we can also use the 4/5 to find out the angle also by using anti-cos 4/5, and then we get an angle. So it will be TA cos angle also, but 4/5 it also can be used as a substitution towards a cos angle, and it will be much easier. So it goes to 0, and then Fy goes to 0. So by using this, we can get that TC and also TA. And for 3D system, it's just the same thing, but with Fz equals to 0. And for this one, right, for this question, as you can see in D is lie on XD plane, XY plane, and for the point C is lie on XZ plane, and for the point B it lie on Y-axis. So Fx equals to Fd sine 30. Fd is point D. Since the D is lying on XY plane, Fd sine 30 minus 4/5 Fc. Fy equals to negative Fd cos 30 plus Fb. Fb is the Fb. You must be curious why Fb is not included in the Fx sequence, right? Equations, but since Fb is not related to axis, so the point B shouldn't be Fb shouldn't be involved in the Fx. So Fy is only negative Fd cos 30 since the point B right in line on XY plane. So it's related at Fb. And for Fz is 3/5 Fc, Fc. Since the point is line on XY plane, so it has nothing to do with the Z axis. And only point C is related. So Fc and then 3/5 Fc, and then minus 90 pound. In 90 pound is the own weight of the hook equals to 0, and then we will get this, and then we will get the Fb equals to 808 pound. And first of all, afterwards we need to find out the extensions using SAB, and we know that according to Hooke's law, the extension of the spring formula goes to F equals to Ks, right? So Fb equals to KSSB, so we can substitute the 0.208 pound at the left side, and then the 500 pound per feet is provided in the questions descriptions, and then we can get SAB extension of the spring equals to 0.416 feet. So next will be force retardant system. So for force retardant system, right? This one is according to rotations. When we are rotating things, right? Let's say having a wrench to rotating a screw, we will generate a force called torque, a rotating force called torque. So in this chapters, we call the torque as moment, which is a rotating force. And F in M equals to Fd. F is the force accepted, and D is the distance between F, the force, and also the rotating pivot. So if you see at the conditions on the example on the right side, question A 4.4a 4-4.4a, MO equals to 100 Newton times 2 meter, and also for Fm equals to Ft to work, right? For this parameter to work, it must be 90 degrees to each other. So the F and D must be 90 degrees to each other. If there's no 90 degrees to each other, it won't work. We cannot use this formula anymore. So MO equals 100 Newton times 2 meters. You can see that it's 90 degrees. And the same thing for B, and for C is a bit special. We need to find out the horizontal force. So it will be 2 feet sine 30 plus 4. And for D is also a bit special. And since we see that it's 60 pound exerted to the right directions, we can't use the 3 feet. We only can use 1 feet sine cos 45. It's sine 45, sorry. Yeah, 1 feet sine 45. We only can use 1 feet sine 45, which is the vertical force. since if we can use the 3 as it doesn't have it is in the same direction as as the force. So there's no 90 degree in between them. It can be used. And for the E example E, as we see that the 7 kilonewton is exerted on the tip on the end of object. So we need to minus it, 4 minus 1. To become 21 kilonewton meter. And you must be curious with the direction anti-clockwise and clockwise shown after the answer in the reference book. So this one, actually in this chapter, we assume that if the object is rotating anti-clockwise, we make it positive. So in the opposite clockwise, we negative. But since in this chapter, no, in this example, is a scalar analysis, so it doesn't care about the anti-clockwise and clockwise first. But however, we have to pay attention afterwards to the example after this. So now we will go into cross products. So cross product is a way to calculate moment also. When there is yes, it's a way to calculate the moment, but this one is much more complicated than the previous one. But however, it's a way, and also we can use FD also. We can still this another way, but still we can use FD. But FD sometimes it will be harder for us to see the answer, so we use RF cross product so that we can solve the question much more easier. So this one, first of all, we need to determine the coordinates of the position A and position B, and then we need to find the unit vector, which is the position, the coordinate divided by the numbering, the value, and then we will get times 2 kilonewton. F exerted is 2 kilonewton, so we get the 0.488 I plus 1.376 J plus minus 1.376 kilonewton kilo, and then K kilonewton. So and then for RAF, right? RAF, MO equals to R times F. For this one, this is a bit special. So these things, I believe that you all must have learned this in secondary school mathematics. This technique, which is the same thing. So first of all, yeah, IJK column, right? And also there are 3 rows, 3 row, 3 column. So for this one, we do it step by steps. So first of all, for I, right, since we need to write the number value for I, we obscure the value of I and only see at the column of JK. So we assign A, B, C, D, A for 0, B for 12, C for 1.376, and then minus 1.376 will be D. So this one, I believe you all still remember AB minus AD minus BC. This one is a way, I think you all must be familiar with these things. So it is the same thing here. So 0 is A, it times with negative 1.376, which is D. So AD minus BC. So BC is 12, and then C is the 1.376. So AD minus BC equals to 0 times negative 1.376 minus 12 times 1.376, and then bracket I. And for the J is very special since we need to insert a negative sign in front of it. So it will be negative sign here, and then we will be using AD minus BC again. So obscuring the column of J, only focus on column of I and K. So 0 times negative 1.376 minus 12 times 0.48 J. And then the same thing goes with K, and then we will get negative 16.5 J minus 5.5 1 J. And also, if we do the same thing with RB, we will just find that they are having the same answer. So which means that no matter in which direction they are rotating, rotating from which point, A or B, they will be having the same moment. So now we'll be going to moment specific axis. So for moment specific axis, right? Since according to it will be a bit different with the example previously I have shown. So sometimes an object can only rotate on specific axis. So in this, if in this case, then we call as movement on specific axis. So as you can see in the question, right? In these questions, there are three axes, and you can see the rectum there. The rectum is quite important in this case. So let us see one by one. For mx, the moment x, we need to consider from every different direction. So 60 pounds times 2. 60 pounds is the y-axis, and times 2 feet is from the height 2 feet. So plus 50 pounds times 2 feet. 50 pounds is from the force from z axis. So it's at B point B times 2 feet. Okay, times 2 feet. And then plus 0. Since for the F3 is the same direction with X axis, so it can't do anything, and so it will be cancelled and it'll be 0. And for my, negative 50 times 3. So y is negative. So from y-axis, right? So we see y-axis at here, right? So it's inwards, right? And for the point B, however, point B is not in here, but in here. So it's opposite with it is against the rectum, our rectum and y-axis, towards y-axis. So this point is against, right? So it's negative. So the same thing as 40 pounds times 2 feet is negative also. So this point, right, and this point, as you can see, this is our rectum, and then is the F force 3, and then it goes through here. So it is against the force, against the rectum, the circle, the cycle. So it's negative also. So the same thing goes to for MZ, negative 40 pounds times 2 feet, which is the same. And for MZY, there are 2 zeros. So let us see one by one. So for force 1 is 60 pounds, but however, there is nothing that there's no D that can be related to with F1, since although for F2, right, for 2 feet, right, 2 feet F1, but however 2 feet and F1 is in the same direction. It's not in 90 degrees, so it can't be used. Since for m equals to mo equals fd, it must be 90 degree. And then for the 50 pound, right? For 50 pound, the force 2 is the same direction as the axis, so it can be used also. So it's the answer. So now we will go to frictions. So friction, if you go, first of all, let us see a picture of a roller on a slope. And a roller, as you can notice, that the roller is supported by, is hang on a rope, and a rope is T, and then we can see W, which is the own weight of the roller, the barrel, and the barrel is on the slope, right? So on the slope, since it is slanted, there's a friction, and although even it's in a flat surface, there's always a friction too. So and the N is a normal, is a tangent to the F, to the force frictional force. So as you can see in the left diagram, there are impending motions. Impending motion is a tendency for the barrel to roll downwards from a slope. But however, there's a friction there, and since this one is there's also a rope, so the barrel is in a static motion, static motion. So the friction will be static frictions and not kinetic friction. If let's say that it's not in equilibrium, the P is greater than the Fs, F, so it will be then the friction will be Fk, since the barrel is rolling. But it's not a kinetic friction, then it will be kinetic frictions. And the phi s, the angle of static frictions is the angle in between normal and the resultant frictional force. And the formula for friction is is the coefficient of static friction times normal, the normal force, the force normal. And yeah. So let's see an example. So so in the picture there's a crate, and also there's a force pushing onward, pushing on the crate which is 80 Newton with an angle of 30°. So as we can see, we need to as you see, and it says that the static friction is the coefficient of friction is 0.3, and it says that it wants us to determine the x, the distance, the distance for the crate to move in order to resist the pending motions. Impending motion, sorry, that is the impending motions. So as we need to first we need to calculate the mass, the weight of the crate, which is 20 kg times 9.81, become 196.2 Newton, and then the pending motion 50 Newton, as we can see here, and 0.1 become 0.2, and NC here, NC is normal to the frictional force. Since it's the frictional, there's a contact in contact with surface, right? So there will be friction, and then there will be, of course, normal, which is tangent to the friction. So as shown is so, we just first of all we just do the same thing. We calculate fx as fy, and then we get this. And later on, we need to calculate the moment anti-clockwise as a positive. Okay, so active sine 30, we need to consider all kind of forces here. Active sine 30 Newton times 0.4 meter. So it's here sine Newton 30 times 0.4 meter. And then 80 cos 30, 80 cos 30, 80 cos 30, 0.2 meter. And then plus NCX to the center, so center. To the center, and solving by doing the mathematical calculation, we can get f equals 69.3 and x equals to negative 9.08 millimeter. So the which will be the last section of my video presentations. So in which it will be a bit complicated since it involves a lot of force, and of course there's frictional force. Frictional force is the main topic, main topic, yeah, being discussed here. So this is an example. So there's a uniform stone, the stone is there, and also there's a wedge, so at point B, and it says that how much force is needed, how much impending force is needed to push the stone. So first of all, we need to calculate the friction force. So as we see, there's MA, right? MA, so we pick up MA, we need to calculate MA. So MA equals to 0, still as we use the equilibrium system, and it will be negative 4905 here, 4905 here times 0.5, and then we will plus MB cos 70, MB cos 70, which is a vertical force, times 1 meter, and here 1 meter, and then plus 0.3 MB, MB sine 7 Newton, which is also a vertical force, times 1 meter. 1 meter here, the length equals to 0. So we get MB equals to 2383.19 by 1 Newton. So why the 4905 will be negative? Since it's a clock, we need to rotate it in the anti-clockwise, right? We perceive anti-clockwise as positive. But however, there's a 4905 here, so it's opposing to the upward force of the anti-clockwise cycle. So it will be negative again. So we find out the x and xy, and then we get the p, and we get a p of p equals to 1.15 kilonewton. So it's just like this. So that's all. So thank you for listening to my presentations video, and most of the example in these slides are taken from a Jane Collip's statics books. So if you are curious or have any questions, you can go and referring to that reference book. Since that reference book is quite in the explanation, its explanation is quite in details. So thank you everybody.